All right, welcome to Doozer's shop. I've got some good stuff going on here today. Happy Easter if you happen to celebrate Easter. It's been a beautiful spring day here, birth of spring, another year. So I've been getting some good work done in the shop. I had Good Friday off from work, and I'm still going into work. Things are okay here in where I live with this virus, but I've been working on the lathe. In my last video I had the apron with the power feed, rocker box, and all the bushings and everything up on the workbench. And now I'll get off the chip pan here and I'll show you, you can see I got everything installed. So let me show you right now. All right. So what I got here, I put the lathe back together a good bit. So this is the carriage. I put the carriage back on the bed waves. Got everything cleaned, and I got the I put ball oilers in here back again. Now. I know a long time ago I said I wasn't a fan of ball oilers, and I'm still not. But I made another redundant feed on the side of the apron, which you've probably seen in my videos. But anyways, it just sort of serves to plug the holes. And if I put the flip top oil cups, it might get in the way, because this surface is T-slots and it's machined flat. In case you want to set something up in the lathe, like an angle plate to do some line boring, whatever. I'd probably never end up doing that because I got a horizontal boring mill, but like I said, nice and clean. So yeah, so this, man, it travels like a dream. It is, all the gears are working fine. And everything's very smooth how it works. Very happy about how all that came together. Got the cross slide on, and this thing, I got the gibs actually, I worked pretty long time to get the gibs set right. There's about 1,000th of clearance as measured with a dial indicator. And I'll get you a close-up when I go handheld of the how the gibs are adjusted. This Colchester lathe has gibs like I've not seen before. But it's very, very unique idea. Very simple how they're made. And then I took the top slide apart. Some people call it the compound slide, the top slide, or the compound. It's also very smooth. The ways, see, all the ways on this machine were in good shape. It's just that everything was misadjusted. The gib in this compound, it bolts into the top, and then it has the pressure screws from the side. Well, the screws were loose when I took it apart, and it's grungy and nasty. And when I cleaned everything and put it together and I tightened the fastening screws, the gib would lock up. And it turns out I had to grind the gib, and I'll show you more about that later. So from the factory, it was too tight, and you could never actually tighten it. Tighten the screws, or else when it's, we tighten the screws, the dovetail would clamp, so I had to grind off the side. But I'm just very happy how all this works. So this is, I think I'm in the shot, yeah. This is that rocker box. And you can see I built all this rod to keep it from coming down too far. And that was the Achilles heel of why this lathe wore out the bushings. with the way the lathe prevented this handle from falling down is it had a little tab on the casting real close to the center line of the bushings, and it exerted it, and it rode along the back of the apron wall, and the little tab or tang would bear upon the apron wall to prevent this rocker box assembly from falling. But in doing so, it was like a crowbar. The tang was so close to the center line of the works, the bushings in the shaft. It was such a just the weight of just the weight of that caused such a force multiplication, and it wiped out the oil film and wiped out the bushing. So I came up with this here, and I'll go handheld and I'll show you a little bit better about that. But the way it goes, you slide it over and you click it up and in, and that's the cross feed, the power cross feed, okay? And to disengage it, you just pull it down. So engage, and then just pop it down. And then if you want to go with the bed feed, push it over, and ideally this should be spinning. There you go. Yeah, this would all be spinning. Out. When you pop it in, you gotta make sure it's lined up with the slot. So, you know, this ain't gonna work. You gotta go over and then lift it up. So that's bed feed, power feed. So that spacer, there's a spacer inside made out of, I was talking about using PVC, I use nylon plastic. And my buddy James there in Virginia, he asked, you know, is PVC going to work? Should you use like an iron spacer? Well, all that spacer does, you see that? That just bounced off the nylon spacer. And there's a washer, a steel washer on this side. And then the spacer. So that's all the force that spacer sees. It's more just to locate the rocker box. Man, that goes in nice, and it's going to go even nicer when the rods are spinning and everything's chooching around, you know, under power. But the only lash in the system is there, and that's the pinion engaging on the rack. But the pinion's really not that worn. The pinion is probably, let's say, 1 inch wide, and the rack itself is probably like 7/8 wide. Of 1 inch. So there's always going to be a little bit of that 1/8 inch of pinion in length that's unworn. And so you can kind of gauge how worn the pinion is. And it's not really worn. And the bearings, bushings are really in good shape. I think that's just a natural gear clearance. But this lathe is, a lot of the wear items were in fine shape, were very good shape. I just had to fix the incidentals. The incidentals are what always kills you. Okay, half nuts. This is the half nuts lever. Half nuts are in. Half nuts are disengaged. Well, it's a single half nut, but you get it. So that's in, and that's out. So I got a nice double spring on my detent ball. There's 2 springs in there on my 1/4 inch detent ball. So it has the proper tension. And I got it greased up. I probably used too much grease. But when it's halfway, that's engaged. There's another detent on top, and actually that's a 1/4 20 set screw. It used to have a head, an Allen head bolt in there to limit the travel, and I didn't know if that was factory or not. So I made it a detent, and actually it does not come up that far. And the half nut is in fine condition. I think it's made to wear in, because you really can't. That's fully disengaged. And I know this is a serrated spline, and you can move this lever around. If I did that and that was engaged there, it wouldn't be fully lifted up and disengaged down here. So I'm happy with that. I really ought to talk to another owner of a Colchester to see how, I have a whole bunch of little itty bitty questions about stuff. But anyways, I'm very happy with how the half nuts work. I know I was scrutinizing that mechanism quite a bit there on the bench. So the half nuts work fabulously. The rocker box works fabulously. Yeah. I surface ground the top of the compound slide while I had it off. And I'll show you that a little closer. Just as a cosmetic thing, because it was all nacquered pretty good. I'm dying to go handheld. I got the camera up on a stereomagnetic base sticking to my bandsaw. But let's go handheld. I can give you a better detail here of what's going on. And you can see the aisleways are kind of narrow here. I got everything kind of apart. All right, let's take a look at this mechanism that I have set up to limit the drop of the... All right, so like I said, there's the edge of the chip pan. There's the rocker box handle. Okay, so that bumps against the stop, and you lift it up. And that's engaged, okay? And just drop it out. And you move, that's the bed feed. You got it kind of, alright, I had to move the hand wheel a little bit. So that's how that works. Alright, so what's interesting is, let me grab the camera here. If you move the carriage, right, that way, nothing happens. If you go this way, the rocker stays, and then it goes over there. And then if you go the other way, the rocker stays, and then it goes over there. And if you go, you get the idea. So it's an odd little affair how it works. Now, of course, that engages the cross feed. Alright, so basically what this is, it's a piece of flat stock, and you can see, you kind of switch hands. Yeah, it's flat stock, and it's just a piece of aluminum with a hole, a blind hole in it. That's the back of the hole. And that's all it is. You can see my my brass detent plunger. That's what clicks in. In there, there's a recessed hole. So that's that. That works pretty well. So Keith Fenner, I think what he did is he just used a piece of flat stock, flat stock, and came down, and then he came across with the flat stock, and he came just up, made the whole thing out of flat iron. This is a 7/16 stainless steel rod, because I've got a pile of this stuff in my metal supply bin. Don't know where it came from, what it is, but yeah, so that's kind of nice. On this machined off area here, I think I'm going to mount the threading dial. I'll show you that later. So I got one oil cup in. Okay, you can see the top of the carriage. On the top of the apron, I put 1/8 inch pipe thread holes. So this will feed, this is redundant. This oil cup will feed all the points that need lubrication in the apron itself. Okay? And I just didn't screw the one in over there. I don't have my way wipers on yet, but that is, I got the V ones made. So that's coming. I'm gonna put that on. So you see I got this stacked up. There's a thrust bearing and such. I don't know if you can see. There is, let me focus it, there you go. That's the clamp for the bed, to lock the bed. And it's kind of cantilevered with nothing supported. It's captured on two sides with that steel block. It's a U-shaped steel block, and the movable block where it's got the bolt, you can see the threads coming out. When you tighten it, it just starts bending the bolt to pinch on, you know, the bottom of the bed. So when I'm shining the light on here is just the frame of it, and that little block to the left is the actual clamping mechanism that's, you know, pulled up by the long bolt. So what I'm going to have to do is re-engineer that so it's not just threaded on the bolt and pinching the edge of the way. Make it more like a strap clamp like you'd use on a milling machine table to affix something, where it has, you know, 2 points pushing and 1 point pulling. This has 1 point pulling, and it's also in bending, and 1 point pushing, clamping the bottom of the table. So, you know, Colchester really didn't think about their homework with the bed clamping arrangement. So whatever, that's going to get fixed. Thank you, flashlight. All right, kind of back you up. I just got my wrench in there. Oh yeah. Hope that's coming through nice. I surface ground this, and the reason I did, I just wanted to look nice. Let me kind of come around with the camera. Here's a ball oiler. I had to recess the ball oiler so it's flush, and that worked out really nice. That just drips oil on the feed screw. Now, I don't know if the glare is going to allow... Okay. You can see the grinding lines and where it didn't clean up. This area did not clean up. So I had to take 15 thousandths off the surface because this whole thing was chowdered back quite a bit. That's where the tool post goes. And I got to make a T-nut. A little spot's missing, but that's nothing at all. But like I said, let me try. Hold on. Yeah, you can see how nice it cleaned up, and then right there you can see a little bit there, but for the most part you can see the grinding lines. It all cleaned up rather nicely. But here, like I said, I'm not going to worry about that because I'd have to take too much off. So, and there's the Gits, not the Gits, the ball oiler for the crossfeed nut. Let's see. Let me go around back. I got everything. I had things in the milling machine, I had things in the grinder. Alright, so, kinda, And you know, there are some you know, where the chuck bit into it. Oops. But it's not bad. Yeah, it looks worse than it is. Alright, enough of that. So the chuck, sometime in its life, was rubbing in the front of that. And it's not bad either. It's just a sign of not giving a care. I should show you my boring mill table. It's in good shape. Brian Block's boring table, somebody let loose with the warpath and got some nasties in it. So here is the taper attachment mounts here. So I'll show you Colchester's dovetail system. So that's conventional, where it's milled, the angle of the dovetail is milled into the sliding part. And here you'll see what the deal is. So that is the gib, and it's the actual dovetail milled into the gib, and it's a straight gib. It's not a tapered gib. And what the deal is this. So there's attaching screws that go up this way, and there's forcing screws that come in from the side. There's a forcing screw, and you might see in the background more. So the forcing screws, I don't know what I guess I'll call them forcing screws. They force the gib up against the dovetail. And on the top, you have, you know, that is the tightening screw, I guess the holding screw. So there's one there, back the whole length of it. So these screws attach the gib, right? I don't know. You trust me that they're under there. So, all right, focus, good. There's actually a few thousandths gap in there. There's maybe trust me, there's a few thousandths gap, or else, because if you tighten that, you can tighten it so tight, and then it just binds the cross slide. But there's enough slop in the holes of the attaching screws that it's able to be forced over, you know, like 5 or 10 thousandths, okay? Otherwise you gotta elongate the holes. So what happened on the cross slide is the gib was too wide, right? And when you tightened it to the top, when you tightened it all the way up, it would, let me back out. It would bind it up without the side forcing screws even tight at all. When you tighten the top screws to suck it up tight, the dovetail would be pushing too much, even though this was just touching the face. There was no, the forcing screws were not even tight. So consequently, I know this is the cross slide, not the compound. On the compound, you know, the gib was loose, and it was loose for a reason. The forcing screws were loose, so it would not suck up tight, and it wouldn't bind sideways. So enough of that. I just wanted to let you know. So I don't know if you can see. It's hard to see when you don't focus. It doesn't like it. All right, maybe you can see the gib there. It's all part of the mishmash of where it hit the chuck, but there's the gib, and that's the one that needed to be ground down, okay? Oop. All right, so what the deal is, all right, had to grind it down. Let's go for a walk over to the grinder. No, I didn't take a picture of this, but I've got two vices, and they're different vices. One's a screw vise and one's a screwless vise. Don't ask me why they call them that. And these have the same height. So when I plopped the gib in here, I was able to grind off the surface where the side forcing screws would push on it. And I ground about 3 thou off of it. Not much. So I ground 3 thousandths of an inch off the gib for the top slide, the compound slide. Still more parts for the Colchester. But just wanted to make this video. I'm pretty darn excited that this thing's working like super nice, super well, everything's just, I spent some time adjusting the gibs and adjusting everything. Just perfect. I'm going to be making a T-nut, and let me kneel down again. I don't know if I can get a shot. Let's see. I don't want, there you go. The underside of the T-nut, I'm sorry, of the slot, or the T-slot, it's a little chowdered up. So I'm going to make the T-nut fit very tightly, and I'm going to undercut, so just the edge of the T-nut bears in the corner of the T-slot. So I'm going to undercut. Might leave an 1/8 inch strip of bearing area, and then I'm going to undercut it so it doesn't force at the outer edge of the slot. Okay. So, like I said, I'm going to just do the extra diligence to make a really tight fitting T-nut because of that. You can see the side adjustment screws, the forcing screws of the gib, and you know, the 3/4 wrench fits that nut. It's a 1/2 inch thread on both sides. And I'm not a huge fan of how they're recessed in there, but that's just how the design is. Oh, there is the oiler. That's actually got a female thread on the oiler that goes on the male pipe. Find those. I challenge you. That oils the half nut mechanism directly. That's one of the oiling system improvements that I made. So that's cool. And also, you might be able to see a white paint marker line on that shaft, and that spins. And when that line is at 12 o'clock, it opens up an oiling port in the bearing to oil another bearing or something. I forget. But that spins, and when it's at 12 o'clock, and it'll naturally come around and distribute oil when you're cranking it. But if you want direct oil, I think it feeds a gear. It feeds a gear or something. Oh, I know. When it's at 12 o'clock, it feeds the pinion. Okay, the actual pinion that rides on the rack has 4 holes in it. If you watch my older videos, you might see it's got little 1/16 inch cross holes, 4 of them. And with that when that white line, and it's milled in there, and then I painted in where I milled it. That oils the pinion. That's what it is. Okay, so when you oil the side oilers or the top oilers, it oils the pinion. Either that one or the one I don't have screwed in yet. That oils the. I can't show you, but it's in there. Maybe I can. Yep, there's the pinion nut, right? Pinion nut, pinion gear. You might be able to see it, there's a hole in it. See that hole? There's 4 of them holes spaced equally around. So that hole and the other ones, you can see what I mean. See the unworn portion to the left and kind of the grainy portion to the right of the gear teeth? Look at the bottom and you'll see what I mean. That gear is really not worn, and the rack does not look worn either. So that lash is just how the gear lash is, and it's not much. I'm just being obsessive. But that hole, 1/16 hole down in the root of the gear there's 4 of them, like I said. And when that indicator is at 12 o'clock, any oil you put in that cup or the cups on top is directed to that gear. So it's kind of nice to keep that gear lubricated. Like I said, I forgot I got to screw in that other oiler. Got that one in there. That machined area, I'm going to show you maybe later. I got a the thread dial was on the other side, right in the way of the chips. So I'm going to somehow mount it there. Oh, and I got some more. No, I can't really see here. Yeah, you go. So there's 2 elbow fittings on the rocker box, and you shine the light on them. I got to feed oil to them, so I'm going to have some hose and some push lock fittings, and I might put some oil cups. I got to put them up kind of high so the gravity feeds them in there. So I might, put them on, some of the bolts here on the front to make a bracket and get some oiler cups there. So that's cool. Let's see. I had to cut off an Allen wrench to get in to adjust the gib forcing screws to get down in there, but that's no biggie. So like I said, those are the screws that tighten the gib in position, and the side screws force it against the dovetail. So that's how Colchester did it. But overall, I'm pretty happy. I got 1, 2, 3, 4. I got one for the back way over there. Got one for the cross feed screw. I got one for the compound screw. There's one right there for the bearing. Do I got one here? Yes. I got one there for the cross slide. So this is a telescoping taper attachment, okay? And let me zoom you in. So there's an outer nut which removes the handle. You'll never have to mess with that. So that inner nut, the smaller nut, I think it's 11/16 wrench it takes. When you loosen that nut, and you just take it completely off, then the taper attachment is in full control of the cross slide, okay? Turning this crank does nothing because there's another spline on that cross feed screw, okay? So when you want to use the telescoping taper attachment, you take that nut completely off, put it in your pocket, don't lose it, and then put it back on when you want to use the lathe like normal, okay? So taking that nut off totally disengages the feed handle and puts the in and out movement of the cross slide it ties that directly to the taper attachment, which is not mounted yet. So anyways, so that's a recap of what I've been doing here. on the Colchester lathe. I'm really stoked. I'm really excited. I've been working my butt off for 3 days in the shop, enjoying myself. I've had a great time because I'm at a point where I can make progress. All the little, you know, the major tasks are done. Making new bushings are done, fitting the bushings, repairing the crack in the rocker box, casting, reboring the rocker box. I mean, if you look at my videos, that was a while ago. And fixing the half nut mechanism, you know, sorting out the engagement mechanism for the rocker box. But I have had my nose to the grindstone. Oh, I got to put in oilers down there, and I got a few other oilers I said already. But this thing, man, when I'm gonna shut off the camera, I'm gonna go set my Aloris tool post on here because this thing looks pretty manly. I really want to put a digital readout on it. I may not. One thing, the cross slide is graduated in radius, not diameter. So it goes to 200 thousandths, and it's actually cutting double that. So a lot of lathes have 400 thousandths dials on them. So it's diameter reading. So what you dial is what it cuts. This one is radius. My first lathe was an Atlas 10-inch lathe, I think 1940 something, and it was radius, and I hated it. So, but either way, that doesn't bother me. Oh, so that's not an original handle. That's an aluminum handle. I didn't make that, but it seems to work. It's not as sexy as you know, the other handles, but I'm going to leave it for now. But just giving you guys an update. I am just totally ecstatic that I'm getting this lathe put back together. I know I keep talking about it. I don't know what else to show you because it's all, you know, all done and put together. But so let me just, I'll tell you one thing here. Let me zip around. So the feed rod, when you put the feed rod in, okay, there's a locking collar. So the SIP is moved over. See the end of the SIP where the round dial is? This feed rod and the lead screw go all the way down when you pull them out, and they just clear that by a ½ inch. So I got the SIP jig bore pushed back so I can pull these feed rod and lead screw out, okay? The British design, you can't take this end bearing off. It is part of the casting. It is bored like on a horizontal boring machine or something. It's cast as part of the bed. Every other lathe I've ever seen, you can take off the end support bearing for the lead screw in the feed rod. Not this one. The quick change box is cast right to the bed. It's got a removable cover with a gasket, but that's another very British thing. Every other lathe I've ever seen, the quick change gearbox was removable. Not this guy. All those holes were bored in place when it was manufactured by some big boring mill or something. You know, I'm just, it's interesting to see how the British do things different than other countries that build stuff. I like the fact that the quick change box is sealed. You can see it's the rocker lever is on a shaft that goes in and out and up and down. That's nice because it's all in oil. Very nice. Oh, here's something I wanted to show you guys. Okay, let me back you up. So that's the Norton change lever.
This lever, it engages the lead screw, or you flip it the other way. Is it that way? Okay, that's in and that's out, I guess. But if you push it down, there's supposed to be another gear there, okay? So that's neutral, that's engaged, that's neutral. And see, there's two dogs there. It's made to have another gear, okay? What the deal is, the British market for these lathes, they included a metric gear. So that would be English, neutral, metric. Here it's just English, neutral, neutral, okay? So when they sold these lathes to America, and this is a Colchester Clausing, okay? The Clausing group, I think, branded it Clausing Colchester. And you can see Clausing Colchester, but you know, this is a Colchester lathe made in England, and this Atlas Press Company, Kalamazoo, Michigan, you know, who owns Clausing or whatever. But enough of that. The Clausing Colchesters, they took out the metric feed gear. So what I would like to know, if it's as simple as obtaining the metric transposer gear and slamming it on that shaft and pinning it on or whatever it's gotta be, and then I can have inch and metric. So I think I need to contact the gentleman I purchased the apron gear from, the feed gear, Frank Kleinworth in Texas, and see if he sells that gear. And hopefully someone's inquired about it before, or else he'll think I'm crazy and not know what I'm talking about. So, okay, so that's that. A while ago, I cleaned up the headstock. I replaced that sight oiler glass. I don't know if I showed it on video, but I replaced the shifter fork, or repaired the shifter fork. This is the forward and reverse for the lead screw, and it should be running. So there's a spring, a ball and a spring to make a detent in there, and somebody had painted the lathe, and the gray paint, it gummed up the ball detent, and the detent was rendered ineffective. Wouldn't hold it in gear. And I guess this is my detective work talking. It kept popping out of gear. So what I think someone did is they put a bungee cord on this to keep it in gear. And when you have a bungee cord on it instead of a detent, the detent just holds it in a neutral position. The bungee cord is constantly pulling, and it wore out the shift fork, okay? So if you see a picture with a lathe or a mill and it's got a bungee cord holding a lever in position, is wearing out the shift fork. It's killing itself. You know, whatever. So that was one of the things that I repaired in the headstock, and good God is it tight in there with my fingers and everything. Okay, yes, I covered that. I'm going to try and get a gear maybe, hopefully. If any of you guys know about this, can I just buy a metric transposing gear and put it in there, and then my lever will work? Let me know. Or even if you got one, if you're in the United Kingdom and these things are more popular and you're scrapping one out, please write to me, email me. So this is the thrust setup for the lead screw. That's a spacer that's broached for a key. You know, it's got a key way. And these are a nut and a jam nut. This sets the thrust. This thing was beat to death by some ham-fisted mechanic. I don't know if I showed it on video, but I spent a couple hours screwing around. I was peening metal back into place with a hammer like a body man would. But that's all beautiful and nice now. The on-off switch goes in there, and the brake lever, direction lever. Yeah. That's about it for now. I'm tired of talking. My coffee's getting cold that I brought out here and set on the table. I'm going to go upload this for you guys to show you the progress on the Colchester 17-inch lathe. Until next time, this has been Doozer's Shop.